Hello out there in Physics 277 students and anyone else out there watching in YouTube land. Today we're going to continue with part 8 of our series on using the Linux command line, and we're going to talk about STDIN, STDOUT, STDERR, and redirection of input and output and error from commands and programs that you write. And this is one of the more powerful features of the Bash shell. Now, to understand this, we're really asking the question, where do Bash shell commands and your programs send their output, and where do they get their input? And this brings up a way that we actually do input and output on Linux and Unix systems. The default is that on Linux and Unix systems, commands send their output to what is called STDOUT. And usually we write this out and we abbreviate it by saying capital STDOUT. So when you see this capital STDOUT, like I've just typed into my terminal there, that indicates this is the standard output for the system. Now, standard output is usually the screen, but it doesn't have to be. But in all practical, in any practical sense, I should say, it means that we're doing output to the screen. And most commands write their normal output to STDOUT. So what do I mean by that? Well, let's suppose I issue a date command here on the command line, and I say date like I've done now. This output, which I'm just about to highlight right now, gets written out to the screen. It is written to STDOUT, that capital STDOUT. It's a notation that we use. We're never really going to have to type that capital STDOUT, but when you see it in documentation and you see capital STDOUT, you'll know they're talking about STDOUT. Now, when we do this, the Bash shell can send standard output to a file, and this is called redirection. Redirection is accomplished through the use of the redirection operator, which is the right angle bracket. I'm about to type this right now. The right angle bracket there, also sometimes referred to as the greater than symbol. All right. On most keyboards, it's probably, if you have a QWERTY keyboard, it's probably right above the period there, so you have to hit Shift to get it. But that's how we're going to redirect standard output. All right. Let me show you some examples of this. Let me first do, in my directory, I'm going to do an ls command so you can see what files I have there. I have 6 files sitting there: a hello world underscore cpp, hello underscore world cpp, a +1.cpp, a hello underscore world, a +1, a file called my command, and lecture underscore 6.pdf. So there's 6 files. Notice that. Now I'm going to issue an ls command, but this time I'm going to type after it the greater than symbol, that is the redirection symbol, right? And I'm going to give it a name of a file that will accept the output from the ls command. I'll just call it output.txt because the output is going to be text, so I'll name it with a .txt tag. When I do this and I hit enter this time, you notice that you didn't see any output written to the screen. And that's because the output was redirected from the ls command, which set its output to STDOUT, and the shell intercepted that output and redirected it into the file output.txt. How do we know that? Well, first of all, let's do another ls here, and you can see now I have a new file here, output.txt. And let's look at the contents of that file. Let's use the cat command, cat output.txt, and you can see it has the output that would have been written out to standard output. This is the list of the files that are there, including the new file, output.txt. So what I did was I redirected that output. Now, I can use lots of commands right to STDOUT. The echo command, which we talked about when we talked about shell variables quite a lot. The echo command, say for example, I say echo bye, right? All it does, it takes its input and it sends it out to STDOUT. Well, I could redirect that. Let me redirect the output there by redirecting the output from echo to the file output.txt. All right. Let me show you what got written into output.txt using the cat command. Oh, I said out and I meant to say output. Okay, And there's the word bye-bye. Now you might ask, what happened to the output that came from the ls command? Before, when I did a cat of output.txt, this is what was in the file output.txt. But now when I did a cat of that file, all right, I got here bye-bye. What happened to the stuff that was written out by ls? Well, whenever you redirect into a file, that file, if it already exists, is overwritten. A new file is created with the output from the current command that you're redirecting the output from. All right, so you should be aware of this. The symbol of using the greater than symbol here, or the right angle bracket to output, is very powerful, but it will overwrite the file. Okay. Now, it is possible that we can append information to the file as opposed to overwriting it. Let me show you how that's done. Let's start again from scratch here. I will I'll execute my command again, ls, and redirect the output to output.txt. Let me do a cat on that file. All right, you can see there's the information into it. This time, I'm going to do the echo command again, and I'm going to redirect its output there, but I'm going to use two right angle brackets, that is two greater than symbols. You can think of this much greater than if you're used to think of it mathematically, all right? And I'll execute this command, all right? And let's see what happens now when I do the cat command, all right? When I cat that file, here's the original output I'm highlighting right here that was written out by the ls command, but now there is a new line here that says bye-bye. That was the output from the echo command. I could do one more. I could tell it the date command and redirect that output into output.txt. All right, and this time when I do the cat, you'll see there's still another line that has been added. So I can append using two right angle brackets in a row, no space between them. All right, so that allows me to append information. Now, I want you to beware that redirecting output this way only redirects, quote, what I'll call normal output. That is output that is written by the program that doesn't go to something called standard error. Standard error, if you see it written in the Unix and Linux literature, is abbreviated as capital STDERR, all right? ERR, sorry. Okay, this is a different sort of output channel that captures output that is written to contain really error messages, all right? Let me illustrate this, all right? When I do an ls command, its output is sort of, quote, normal output, unquote, all right? But what if there's an error in executing the ls command? Suppose I do something like ls xyz, all right? Now the xyz file here doesn't exist, so when I do ls and give it a name of xyz, there's no file or directory named xyz, so I get an error message from ls. Let's see what happens when we try to redirect things. All right, when I redirect ls to output.txt, like that, we don't see any output. But let's suppose I do ls xyz and redirect this. What do I get? Well, I still see output. Why is that? It's because this output right here was sent by the ls command not to standard out, but to another channel called standard error. All right, and it represents sort of a different channel for doing output. It ends up here on the screen, but it wouldn't be captured by redirection. Now, is it possible that I could redirect this non-normal output? The answer is yes, there is a way to do it. I can capture both the standard error and standard output from a file by doing the following. When I use the right angle bracket, in this case, I'm going to append immediately after that with no spaces an ampersand. And what this does is it tells the bash shell to capture both the standard output and the standard error and send it to the file output.txt. Let's try this. I'll issue that command, and you see there was no output to the screen now, and let's do a cat on that file, cat output.txt, and you can see that error message, cannot access xyz, no such file or directory, was now written to the file. All right. So there may be times when you only want to capture the normal output, and you can do that by basically saying just use the redirection symbol like this. There may be times when you want to capture the standard error in addition to the standard output from a command, and you can append an ampersand here. By the way, this has to be immediately following. If I put a space here like this, all right, I'm going to get a syntax error from the bash shell. All right, so when you want to redirect both standard output and standard error, you have to have no spaces between the greater than symbol, that is the right angle bracket, and the ampersand. When I do that, this works fine. It will capture that output. Again, if I do cat output.txt, you can see that it captured that error message that would have been written out. Right? Your Fortran, C++, and Python programs can write to standard error in addition to standard out. All right, I'm not going to cover that here today. It is also possible to redirect the standard output to one file and the standard error to another file, and I'm not going to cover that here today. That's sort of a more advanced topic. This is really sort of the basics of the shell and how to use it. All right, but it is possible, and you can look that up. There's some excellent YouTube videos about redirecting standard error. You can just Google STDERR on YouTube, and you'll find videos that will describe for you how to do that. Okay, now, in addition to output, how do commands get their input? Some commands take input from things. And I'm not talking about command arguments. When I say, for example, when I say lsxyz, I'm not considering xyz as an input to the file, or the executable, I should say, ls. Right? This is a command line argument, and I'm not talking about command line arguments here. I'm talking about the command may prompt you to do input, or your program may prompt you to do input. All right, here's an example. I wrote a little program in C++. It's here in the file. It's in this file +1.cpp. All right, all it does, you type in an integer and it adds 1 to it and writes it back out. Let me illustrate that for you. +1. It's a trivial little C++ program. In this case, it doesn't issue a prompt, but if I type in a number, let's say like 3, it'll write out 3 + 1 is equal to 4. Or if I type in 17, it'll write out 17 + 1 is equal to 8. All right. This command gets its input from something called STDIN. And STDIN, when you see it in documentation, is usually abbreviated STDIN, all in caps. All right. So you should know these things. You should know STDOUT means standard output, STDERR means standard error, and STDIN means standard input. Now, on most systems, this would be the keyboard. In fact, I don't know of any system where standard input would come from anything other than a keyboard, but it could in principle be some other device on the system. All right. The language standards don't say anything about that. They just simply say, we'll take input from the standard input device of this system, which in most cases is going to be your keyboard. And in this case, when I read in a number in +1, this program that I wrote, and I put in 14 here, and I hit enter, it reads that integer in 14, adds 1 to it, and writes it back out to standard output. So I can, in addition to the redirection of standard output, redirect standard input. Let me illustrate that. Let me put a number into a file. All right. How could I do that? I could use Emacs to do it. That's one way to do it. I can just use the echo command to do it. What I'll do is I'll say echo, and I'll pick a number here like 33. All right. And I'll just redirect that. Oops, I didn't mean to type ## there. I'll redirect 33 into a new file. I'll call it input.txt, indicating this is just plain text. All right, let me do a cat on that file, and there it is, 33. I can tell +1 to accept its input from the file instead of accepting it from the keyboard. How can I do that? I can use the left angle bracket or the less than symbol. Here's how I'll do that. I'll say +1, and I'll tell the shell that +1 is going to accept its input from the file input.txt. I'll say less than input.txt, or left angle bracket input.txt. When I do that, notice I didn't have to type a number in now. I didn't type in 33, but it read that 33 out of the file and it used it as input to the program, which wrote out 33 plus 1 is equal to 34. All right. So that's very useful. We can use that at times. You wouldn't typically do this when you're going to enter a single number, but if for some reason your program, all right, that you write reads in many inputs one after another, you could store those all in a file and have the program accept its input from that file. That's perfectly permissible to do, and I often do that when I have a program where I've got to enter a lot of inputs and I'm testing that program, for example, so I'm running it over and over and over again with the same inputs. I'll put them all into a file, redirect the input from standard input to take it from a file instead. Now, I can do both redirection of input and output simultaneously. All right, here's an example. I'll tell +1 to take its input from input.txt and put its output to output_new.txt. All right, when I do that, you saw nothing got written to the screen, and I didn't type anything in. I just hit enter. And if I do an ls, now you'll see there's a new file, output.txt. And if I do a cat on that, output_new.txt, I'm sorry, you see it captures my output line. It doesn't show you the input, all right, because that wasn't typed. It came from a file. So this can be very useful at times when you are testing a program over and over and over again. All right. So there are lots of things that you could do with this. Right. You could output your information into one file, output your standard error into a separate file, and take your input from a third file. It's all perfectly permissible. Okay, so that covers the topic of redirection of standard output and redirection of standard input and standard error. So if you have questions about this, please see me during office hours. Post a comment below the video here. I will respond to it. And otherwise, I will see you here next time.